Okay, so for this one, I first of all cleared A to Z because remember I just defined M. I want to use the same matrix, but I don't want to keep the value there. So I go menu number one actions and clear A to Z. So delete the defined number. So I don't want that number anymore. So and then I try to solve. Okay, I solve for what? Solve for the dot product of, where is that equation? I solve the dot product of OA and OP. Your OP is still the same OP because your P is still on AB and it's still AP equals to M times of AB. And it's exactly the same as the previous question. So your OP stay the same. So your OP is still this OP. Okay, that doesn't change. It's only the value of M will change. Okay, to give you different things. So your OP stay the same. So you're basically trying to solve this equation. Okay, trying to solve this equation. So your dot product of OA and OP over 5 equals to the dot product of OP and OB divided by 3. So what I have done is just put this into the calculator. So dot product of OP times OA divided by 5 so equals to the dot product of OP times OB divided by 3, and I'm trying to solve for M. That's all I want to do. So I'm trying to solve for M, and that gets solved. M equals to 5 over 8. And then I define M again. So M is 5 over 8. And I recall OP again. Okay, recall this matrix again. And that matrix is 7 over 4, 5 over 4, and 1 over 4. So that's the solution for OP. Remember that matrix represents OP. And if you get that matrix solved, you have OP vector. Yes? Uh, Oh, you can do that as well. Yeah, you can do that as well. You can go given and then M equals to 5 over 8. Same thing. It just, I'm just so get used to use the control VAR button. Like I think it's just easy to use. Just all on keyboard, so I don't need to select anything. But it's the same function. Okay, everyone. I don't want to use hand approach to solve this one. It's ridiculous to ask you to solve this by hand, which means you need to know how to use calculators for it. Okay, you need to know how to use calculators for it. Any questions for this exercise? Do we have any questions for this one? Okay, if no, okay, I will use about another 10 minutes to go through geometry proof. Okay, it never really appeared on the exam, to be honest. It's only ask you to show vector A is parallel to vector B. That's all they ask you so far in the VC exam. But it doesn't mean it won't appear this year. Okay, so we need to prepare for it. What's the two things they likely to ask you to prove? One thing is parallel, okay? The other thing is perpendicular. So how to prove is parallel? If you can give vector u equals to k loss of vector v, if you can show that relationship, that's parallel. So if you want to show they are perpendicular, you will have their dot product equals to 0. So it's u dot product v equals to 0. That's it. That's the key concept for this exercise. Okay, nothing new. That's what you will use. Okay, for the entire exercise. So let's have a look at this question. Prove that the diagonals of a rhombus are perpendicular. So, well, my one is not really good, but I can just go OA, OB, OC. What you can talk about for OA, OC, AB, BC? What you can say about them? They are same magnitude. So if I go OA in this way, OC in this way, I say this is vector A and this is vector C. Okay, so I will give two vectors. What you can say about vector AB? What's this vector? C. And what's this vector the CB. A, correct. And then what I want to talk about is the diagonal. Okay, so if I want to talk about the diagonal is perpendicular, you must be able to show their dot product, their dot product are zero. So what is OB? OB is OA plus AB. So OA is A and AB is C. Okay, so it's OA plus AB gives you OB. So that's A plus C. And the other diagonal is AC. AC equals to AO plus OC. Or you can use AB plus BC, I don't mind. Doesn't matter which one you take, the results will be the same. AO is minus A and OC is positive C. Question, what's A dot product A? What that equals to? Magnitude of A squared. Okay, that's really important. You must remember that. We will use this in geometry proof as well. So now I want to see what's the dot product between OB and AC. Okay, OB is A plus C, dot product of minus A plus C. As I said, vector dot product is same as there's a time sign and all the rules is still possible to use. So I can expand the bracket as you do number extensions. So what we have is minus A dot product A minus A dot product C plus A dot product C and plus C dot product C. Just go extension. Well, you may extend different order with me, but you should get the same thing. These two just get cancelled because it's minus AC and positive A dot product C. I don't care what's the dot product, you will have the same result here. So what I have here is minus A absolute plus C absolute squared. What we just say about the magnitude of A and C, they're all the same because it's a rhombus and it's all the same. Okay, all the lengths are same magnitude. So the magnitude of vector A and the magnitude of vector C are the same. Therefore, that's 0. So you will make conclusion OB is perpendicular to AC. As I said, it's easy. It's either ask you to show is perpendicular equals to 0 or it shows parallel, which you can say U equals to K loss of V. That's all you need to show in the end. Okay, so there will be hard questions, but the key idea is this. And they won't ask you extremely hard, difficult proofs. Okay. Example 19. Prove that the angle subtended by the diameter in a circle is a right angle. So I draw a circle here and I draw a diameter here. Angle subtended doesn't matter where, okay? So I'm talking about this angle C. If I say this is O, this is A, this is B. And if I can connect for BC, that's BO plus OC. And BO is positive A, and OC is positive C. Sorry, C. Okay, so now again, I want to find the dot product. So AC dot product BC. So still to the extension, it's exactly the same as the previous question, if you can remember. That's if you look up, that's exactly the same. And that's minus A absolute squared get cancelled plus C absolute squared. What do you guys say about absolute A and absolute C? Reason? Their radius.